My name is Firdaus Metajarifin. So for introduction, in mathematics, the term eigenvalue and eigenvector are used to analyze matrix and linear transformation. They are employed in numerous fields, including physics, engineering, economics, and more in the real world. Eigenvalues and eigenvectors, for instance, are used in economy to estimate how the economy affects industry like banking, financing, and investment. They are employed in physics to compute the behavior of objects and particles in various systems, including fluid dynamics, classical mechanics, and quantum mechanics. My name is Firdaus Mintajarifin. So, method of assessment involve assessing different methods of solving a given problem by using numerical techniques such as finite difference approximation, numerical integration, and numerical optimization algorithm. Next, to determine the relative efficiency, accuracy, and applicability of the various numerical methods being tested. The one is possible to assess the effectiveness of several numerical approach on a particular problem by taking into account things like accuracy, stability, computational expense, and algorithmic order. To ensure accuracy in the assessment, numerical methods must be tested over a wide range of conditions and the result evaluated. Tested on multiple of varying complexity allows more robust evaluation of the numerical methods and better understanding of their efficiency. And last one, can make some comparison between the outcomes of the computation and those produced by the software based on the result produced by the software or coding language.
Hi, my name is Khalid Iskandar Razim. My number metric is CD210136, and I'll be talking about the real-world problems that involves numerical method calculations. So first, I'll be talking about optimizing traffic signal timing to reduce congestion. So basically, a traffic light system is a collection of signaling elements positioned at intersections and other places to manage the movement of pedestrians and vehicles. There are three lights: red, yellow, and green. Red, yellow, and green make up the most typical kind of traffic signal. When the signal is red, traffic must halt and cannot cross the crossing. Vehicles should drive with caution since the yellow light serves as a warning that the red light is soon to come, and vehicles are free to cross the crossing when the signal is ring. However, it's no secret that traffic lights are frequently cited as one of the causes of congestion. The issue is mainly caused by the timing of the traffic signals. Other factors, such as the lack of maintenance and the development of a new infrastructure, are also contributing to the issue. Scholars are currently searching for a practical and affordable solution to this issue. So the question is, how can we find the eigenvalues and eigenvectors of a traffic light control system model to analyze its stability and performance under different traffic conditions? Next, I'll be talking about the two-mass vibrating system. So basically, a mechanical system with two interconnected masses that have the ability to vibrate or oscillate is referred to as a two-mass vibrating system. These kinds of systems are used in many different applications, including machinery, automobiles, and buildings. To comprehend the system's dynamic response to outside influences or disturbances, its behavior can be statistically modeled and evaluated. Vibration analysis, or mechanical vibrations, is the study of such systems. A technique for evaluating the dynamics of a two-mass vibrating system is to identify its normal modes of vibration using eigenvalues and eigenvectors. A system's behavior under particular circumstances is described by the mathematical notions of eigenvalues and eigenvectors. A system's natural frequency is represented by its eigenvalue, which is a scalar value, while the direction of motion corresponding to that frequency is represented by its eigenvector, which is a vector. Using the equations of motion for the system to discover the value that meets the eigenvalue equation will allow you to determine the eigenvalues and eigenvectors of a two-mass vibrating system. So next, I'll be talking about the stability of fluid flow in fluid mechanics. So basically, what is the meaning of stability of fluid flow? So the stability of a fluid flow refers to the ability of the fluid flow to return to its initial state following a disturbance. An unstable flow won't revert back to its former state after a slight disturbance, while a stable flow will. In fluid flows, there are two different types of stability: absolute stability and dynamic stability. Dynamic stability is the ability of a fluid to return to its initial state following a small perturbation without the aid of outside forces. Absolute stability, on the other hand, is the capacity of a fluid to resume its initial state despite the existence of outside factors. So, in order to prevent any potential problems like vibrations, noises, or hazardous situations, it is crucial to make sure that the fluid flow is stable when designing aircraft, ships, and other moving objects that operate in fluid environments. This also applies to designing industrial processes that use fluid flows.
Okay, my name is Muhammad Syari Kuan bin Mamat, CD 210113. Today I would like to present about result and discussion. So for the result, from the free body diagram, we get two equation. The first one is mx1 double dot plus k1 plus k2 x1 minus k2 x2 equal to 0. So for the second equation is we get m x double dot 2 plus k2 plus k1 in bracket x2 minus k2 x1 equal to 0. So from that we change into the metric form. So we get negative k1 plus k2 over m and k2 over m, k2 over m, negative k1 plus k2 over m, x1 and x2. We expand x to x1 and x2 and equal to x double dot 1 and x double dot 2. So from that uh neg- we let the metric form negative b, negative beta, alpha, alpha, negative beta s equal to x double dot. So we get beta k1 plus k2 over m, alpha k2 over m, x equal to x1 and x2. So from that, from the equation for oscillatory, s equal to v e power of j omega t. So we expand the v1 and v2. We change it into metric form. Negative b alpha, alpha, negative bs equal to negative omega square x. So from that, we get a plus omega 2i equal to 0 equal to omega square minus beta alpha alpha omega square minus beta. So we get the general equation omega power of 4 minus 2 beta omega square plus in bracket omega square minus alpha square equal to 0. So to find the root, we need to use root formula and we get the roots is beta plus alpha and beta minus alpha. So if we let k1, k2 and m1 equal to 1, so we get the omega 1 square equal to 3 and omega 2 square equal to 1. Next, we need to find the first eigenvector. So for the first eigenvector, we use formula a plus omega 1 square I in bracket v1 equal to 0. V is the eigenvector. So this a negative 2, 1, 1, negative 2 plus we get omega 1 square is 3, so 3003 v1 equal to 0. So we get the eigenvector first is 1 and negative 1. For the second eigenvector, use the same formula and just change the omega 2 square is 1001. So we get the second eigenvector is 1, 1. Next, we move to general equation motion of for two mass. So for the general equation, xt equal to c1 v1 e power of j omega t plus c2 v1 e power of negative j omega 1 t plus c2 c3 v2 e power of j omega omega 2 t plus c4 v2 e power of negative j omega 2 t. So we can let C equal to gamma, and E power of j omega t equal to cos omega t. So we put in the equation, so we get the new equation. So for next, we need to use initial condition by letting t equal to 0. So when we let it equal to 0, we get the equation is x naught equal to gamma 1 v1 plus gamma 2 v2, and x dot 0 equal to omega 2 gamma 3 v1 plus omega 2 gamma 4 v2. So by using zero condition, we can get uh, we can know that gamma 3 and gamma 4 equal to 0. So we get the new equation, which is x t equal to gamma 1 v1 cos omega 1 t plus gamma 2 v2 cos omega 2 t. This is next, we need to find the unknown coefficient. So for the unknown coefficient, we need to let v equal to v1 and v2 into the matrix form, and we get 1, -1, 1, 1. So by using zero condition, x naught equal to v in bracket gamma 1 and gamma 2 equal to gamma 1 v1 plus gamma 2 v2. So to find the unknown coefficient gamma 1 and gamma 2, we can found by inversely matrix form v and multiply by x naught. So if we let x not equal to 1, 0, so we get the answer for the gamma 1 and gamma 2 is same, which is 0.5. For the discussion, to ensure our result is correct, so we use free mat to validate the answer. So you can see from the free mat, A is the metric form, -2, 1, 1, and -2. So in the second row, we have VD equal to eigenvector A. So V is eigenvector, D is eigenvalue, and A is matrix form. So we get the answer V for the eigenvector is 0.7071, and negative eigenvector 1 negative 0.7071. For the second eigenvector, we get 0.7071 and 0.7071. So if we let the initial condition, which is its initial value 1, 0, so we get the gamma for the we get the unknown coefficient, which is gamma 0.7071 and 0.7071. So from that, we can assume that vector and gamma has the same ratio, so we can let it have the same answer. So from the table, we can see manual calculation and free mat calculation, we have the same answer. So the percentage error is 0. That's
Hi, Assalamualaikum. My name is Wadum Hakim Biwan Aslan, CD 20047, and I'll present my part, which is conclusion. As stated before, numerical methods is very close and related to daily life without realizing it. For example, the analysis of vibration problems for a basic lump parameter system using a very simple system in detail. All in all, the student was able to complete the assignment successfully and all of the objectives have been achieved. In this task, students used the appropriate numerical method to determine the eigenvalues and the corresponding eigenvectors of a mechanical system. In specific, the time taken and the values of motion such as displacement, velocity, and acceleration were calculated from the general equation. Students also able to apply suitable numerical method by using mathematical software such as MATLAB in this assignment. Other than manual calculation, software MATLAB also is used to find the eigenvalues and eigenvectors and then compare it with each other to see whether it is correct or not. Finally, students get engaged in lifelong learning through a guided tasks on their own. This means the cooperation among the members to complete the task will help them in future.